Hello, we're looking in your Pre-Calculus Part 2 textbook. This is Lesson 9-3 on parabolas. Specifically, this is example number 5, found on page 906 of your textbook. This one, we're finding the parabola with a vertex at HK. Now, I have already done a video for example 4 that has a lot of the previous detail that you probably need to know. A couple of things are different about this particular problem. One is that this problem is in general form here, which means everything's on one side and the other side is equal to 0. So we're going to have to change that into a form that we know parabolas are, which again is in previous pages to tell you what that is. Secondly, because the y is being squared, I know that this is going to be a sideways parabola rather than an up and down parabola. Now, as we begin to work on this, we're going to take this general equation, which is right here, just recopy. We're going to get the y's together, which is just this part. Anything else, which is this and this, gets moved over to this side. So the 12x becomes negative 12x, the negative 23 becomes plus 23, because we're moving it over the equal sign to the other side. Now, secondly, we're going to do what's called completing the square, which you've done in previous math. That's where you take half of this middle term, which is 2, you square half of that. Half of 2 is 1. If you square 1, you still get 1. And then you have to remember that whatever you add to one side of an equation, you must always add to the other side. So there's why there's a plus 1 over here. Now, why do we do that? Because now, by adding that 1 in, we've created what is called a perfect square trinomial. Y squared plus 2y plus 1 now will factor into y and half of that middle term, which happens to be y plus 1 quantity squared. By doing this part right here, it allows us, it makes this a trinomial that can easily be factored into y and half of the middle term squared, which is what this is. If I clean up the other side, I'm going to get negative 12, and then 23 plus 1 ends up being 24. Now, to be in standard form, this needs to be in parentheses as well. So notice that I can factor out a negative 12 because it goes into both of those numbers. So if I factor out a negative 12, I end up with x minus 2. That's just taking a negative 12 out of that right there. And that way it'll look like what we call the standard form of a parabola, which is y minus k squared equals 4p times x minus h squared. Now this looks like standard form. Okay. Now, because of that, let me go over to the next page. Because of that, we know, first of all, that our vertex, because in general form it's always a minus, so the vertex, the h value is going to be 2, and the k value is going to be negative 1. All I simply do, rather than doing all this, and I know the point they're trying to make, but I would just take the opposite of this and the opposite of that. So your y value is going to be negative 1, your x value is going to be 2. So if I go to 2, negative 1, and I make a dot, that becomes my vertex. Okay. Now the second thing is, and again, I always approach it, if you'll look back at example number 4, I approach this rather than from formula form, I approach it from the visual form because I think most students get it a little bit better. If the vertex is at 2, negative 1, which is right here, then again, we know this is going to be a sideways parabola, but one thing that helps us is this value right here, the number in front of the parentheses, is always equal to what's called 4p. Now, if I set 4p equal to negative 12, right there, because that's what negative 12 represents, is 4p. So if I set those equal to each other and solve, I'm going to find that p equals negative 3. And again, because the y value is being squared, I know it's a left and right parabola. And I also know from that chart on previous page that when p is negative, it's going to open to the left. So from my vertex, I'm going to go 3 spaces to the left, and I end up with my focus being right there, okay, which is 3 places to the left. If I go which happens to be -1, -1. If I go 3 places to the right, that's where my directrix is going to be. Now, directrix is not a point. Directrix is a line. As you can see right down through here, this is a line called the directrix. Because it's going vertically through x equals 5, then that's what the directrix is, x equals 5, and that's how you can find it. Now, they show you how to use the formula, which is given in that box on the previous page. But I think if you'll approach it from a graphing standpoint, it's much more visual, and I think it's much more easier for you to be able to see the answers rather than just kind of plug and chug. Because you'll get, to me, you'll get lost in those particular formulas. Now, the only other thing I want to mention to you is it takes a little work, but if you were to solve for y, because that's the only way to get something into the calculator, and because this is squared, you're going to have to do a y1 and a y2, because you're going to have to use quadratic formula technically to be able to solve this. But anyway, long story short, you're going to get -2 plus the square root of 4 minus all of that, and then you're going to get -2 minus. When you graph both of them, then you're going to notice that it is a sideways parabola, which is very, very, very similar to the one that we sketched up here, right there. Okay, it's just showing that the calculator will do that. But many times it's more difficult to try to get it into the calculator than it is to just do it by hand because of all the algebra that is required to get the y value by itself. Okay, so good luck. There's, again, a lot of tedious information about parabolas, and that can make them very difficult just because there's a lot of things to remember. But if you'll approach it from the graphic standpoint rather than the formula, I think you'll be better off. Best of luck.